Welcome again. I hope you all can hear me. Welcome to this day 4, where we're going to cover in brief the different dimensions of machine learning. We'll briefly recap two main algorithms which we studied till now, which is basically both of them unsupervised learning. Then we'll also briefly recall the Veka tool, which we started work on. So if you have not gotten access to Veka tool, look at the mails which were sent earlier. You can otherwise you can download Veka from internet itself. It's a pretty popular tool. It needs Java. And we will show basically some of the key concepts in Veka in terms of how Veka can help in immediate understanding some of the key concepts from machine learning and put them into testing fast and quick. And that is the power of a tool like Veka, which is a very powerful tool. Actually, it has come from some machine learning researchers, and it's very powerful in terms of the breadth and depth of the machine learning algorithms it supports. So we actually went through two main unsupervised learning algorithms yesterday, and the other one is the association rule mining a priori algorithm. Both are very marquee algorithms in the sense that they're simple, but they form the powerful base of a large number of real life problems we see in machine learning usage in industry. Some of them are probably very focused on retail industry, like the example we saw yesterday of retail data from a supermarket, where we saw that association rule mining allows you to identify which are the most commonly occurring association rules, which tell you which pairs of items, or actually which group of items we saw that given no prior knowledge of a model, how just looking at the whole data, we're able to get patterns hidden in the whole data in form of clusters which they're representing. So today we will like to repeat some of that, and then at the end we will also start with some basic supervised learning method, which is the simplest of them all, which is a linear regression, and continue with more complex supervised learning methods the following days. By supervised learning method, as you are already aware, the basic difference is that you have the notion of a target class to which you want to classify your data, or you want to identify a equation or a curve representing the output variable in terms of the input variables, and that becomes a regression problem. So either we do regression or you do classification, typically in a supervised learning. Whereas in unsupervised learning, we typically do clustering or identification of associations between different data items. So if you see what we want to do typically in large unsupervised data, we either want to find patterns of relationships between different variables, that is association, or we find clusters of similar data points. So to give an example, let's take example of if we have a large population of crowd gathering from, say, and suppose you're supposed to prepare meals for the whole organization. You may want to create just 3 tents for such a large gathering. One will say is pure vegetarian, another is something like vegetarian. Then we may want something where we have some non-vegetarian. Another we may have specifically more focused Jain meal or something. Then we see where the crowd goes, and based on the crowd scattered among the crowd, we'll find out that there are these clusters which are emerging among the people who like vegetarian meal, or those who like egg meal, or those who like pure non-veg meal, or more purish Jain. So what we are trying to see here is that we will be able to identify patterns of similar data items who occur or who closely work with together or who have similar interests. So that is kind of a hidden intrinsic pattern within the whole data, and that gives you the pattern hidden in your data. So that's what unsupervised clustering algorithms try to do. They try to bring out the different similarity of behavior, a crowd of similar people who behave similarly in the crowd. So as I said already, we have covered both supervised and unsupervised. There's another category of learning, we call it reinforcement learning. It is basically a algorithm which tries to build a role kind of a behavior where you don't give any prior information about what is a next step or what is the deterministic step which is to be taken, but there's a notion of a game kind of a system where you're rewarded for certain positive behavior and punished for negative behavior in terms of how far you are from a goal which is given. So reinforcement learning is a very strong emerging area of learning, which is very prominent in the area of games and also in robotics, where you try to steer a robot towards a goal. So there we try to look at how you can define goals at each stage and how you define rewards at each stage and how you define punishment each stage. So that's a different ballgame. It's not in the purview of current thinking, because in the commercial world, so reinforcement learning is yet to take off in a big way. But we feel that as we go forward in more and more unsupervised learning scenarios, which have large data with goal-directed behavior, reinforcement learning may become more mainstream.